Good morning, one and all. This lecture is for B.Sc first year physics students. Paper number 1, semester number 1. Paper name is Mechanics, Properties of Matter. You are welcome in Sanjeevanee Mahavidyalaya Chapoli, run by Navyuvak Shikshan Prasarak Mandal Chapoli. In this lecture, we have to discuss about very important concept of fluid, that is viscosity. What is viscosity? How it is measured? What are the different methods of measuring viscosity? And what are the applications of viscous fluid? All these things we discuss in detail in this chapter viscosity. Now let's turn towards the actual syllabus of our viscosity. Viscosity, the term viscosity we can express in terms of coefficient of viscosity. First of all, we should know what is viscosity. Viscosity is nothing but, or is defined as, the degree up to which a fluid resists the flow under an applied force. It is measured by the tangential friction force acting per unit area divided by velocity gradient under conditions of streamline flow. Then question arises, what is streamline flow? What is turbulent flow? All these things we shall discuss later on. So at present, you remember, viscosity is nothing but degree of to which a fluid resists the flow under an applied force. There is a resistance to the flow of fluid. That term, you remember, is related to viscosity. Then I will show you one picture. Then you will come to know which one is more viscous and which one is less viscous. If we compare two fluids in next picture, in coming next slide, easily we can understand which one is viscous and which one is not viscous. I will show you. See, this container contains water and here syrup. You try to stir it and you try to stir syrup also. You are getting it? Then which one you feel easy to stir? Either syrup or water. Then easily you can answer that water is very easy to stir compared to syrup. What it shows? What it shows? Its viscosity, viscosity of water is less. It is opposing less, resisting less, resisting to the stirrer less. And here opposition is what? More to the stirrer as compared to water. So that we can say syrup is more viscous compared to water. We can say that, in other words, viscosity of syrup is high compared to the viscosity of water. From this picture, you might have clear the concept of viscosity. Which one is more opposing? In these two examples, if we compare these two, surely syrup will oppose more. It resists more. It means its viscosity is high compared to the viscosity of water. And what is coefficient of viscosity? What is its formula? Coefficient of viscosity, the force of friction between two layers of a fluid. having the area in square centimeter and separated by distance will have a velocity is given by. Here it is given. What is given? Force of friction between two layers. Suppose this is one layer and this is another layer. They are moving, flowing, fluid is flowing. Then surely what happens? There exists a frictional force between these two layers. Suppose this one is bottom layer in a pipe or of a fluid, and this is its adjacent layer, upper layer we say. Then while moving this, what happens? They resist. There exists a force of friction, and that frictional force cause to resist the flow of fluid. So the force of friction between two layers of fluid having the area in square centimeter and separated by distance will have a velocity, and it is given by force is directly proportional to area into dV by dx. F is directly proportional to A into dV by dx. Now, how viscosity is to be measured? The viscosity is calculated in terms of the coefficient of viscosity. It is constant for a fluid and depends on its liquid's nature. See, viscosity depends upon what? Viscosity surely depends upon the nature of the liquid. I have shown you two fluids, water and syrup. The viscosity of water is constant. Viscosity of syrup is also constant. Their viscosities are different. I mean, viscosity varies from fluid to fluid. I mean, from nature of the fluid to the nature of the another fluid. I mean, fluid to fluid. Viscosity, what happens? Varies. So we can say that viscosity is calculated in terms of coefficient of viscosity, and it is surely constant for any fluid, and it depends upon the what type of nature of the fluid. So surely we can say that viscosity depends upon nature of the fluid. If fluid is varied, its viscosity also varies. The Foil's method is formally used to estimate the coefficient of viscosity, in which the liquid flows through a tube at the different level of pressure. Very important concept. In Foil's method, the liquid flows through a tube at different level of pressure. I mean, fluid flows through the pipe with different pressure. Pressures, if we improve the velocity, surely what happens? When one has to apply pressure. Then force that we applied is directly proportional to dV by dx we have seen. And if we remove the proportionality sign, here we utilize a constant that is said to be coefficient of viscosity. Here it is shown. Yes or no? So F is equal to eta A dV by dx. F is equal to eta A area into dV by dx. So where n eta is what? Coefficient of viscosity, and you may ask what is meant by dV by dx. dV by dx is nothing but the velocity gradient. An important rheological measurement that is closely related to resistance to flow is called as viscosity. The viscosity of a fluid described as the resistance of liquid. You know, in case of uh, electric current also, we utilize a regulator in order to change, in order to improve, or in order to decrease and increase the speed of the fan. What that regulator is doing? That regulator is going to resist to the flow of current through the wire towards fan. So regulator is nothing but the resistance of electric current. Likewise, resistance to flow the fluid through a pipe or through any device is nothing but the viscosity of the fluid. For example, liquids like water, alcohol, petrol, and more flow freely and faster than glycerin solution. You compare flow of kerosene and flow of milk, flow of honey and oil. This is because of its physical property and is called as viscosity. In simple words, we can explain, or it explains the fluid's flow or resistance. What is viscosity? Viscosity in simple language one can understand, and that is nothing but what? Fluid's flow resistance. Already I have told you, you try to pour kerosene and you try to pour oil. While measuring the kerosene, we utilize cylinder, we utilize a container, we utilize a measure. While pouring the water, while pouring milk, while pouring oil, we utilize cans. These cans are also different. I will show you. Very important. What is this? This can is used to measure kerosene and to pour kerosene. Yes or no? While pouring the kerosene in another can or in another container using this container or this can, you imagine, or you can observe the flow of kerosene through this can. And if we think about this jar, it's used for oil measuring. Then question arises why we utilize such a jar for measuring oil and why we utilize such a jar for measuring kerosene. Because we utilize such a cone-shaped can for kerosene. First of all, you should know which liquid, which fluid, kerosene or oil, has more viscosity. Surely we can say oil is more viscous compared to kerosene. So that by thinking or by taking into consideration their viscosities, we utilize different types of cans for measuring the viscosity of for measuring the quantity or for pouring the different types of fluids. Got it? So it explains fluids flow resistance. It is given. Liquids like water, alcohol, petrol, and more flow freely than the glycerin solution, honey and oil also. Glycerin solution, honey and oil. These fluids are what? More viscous compared to what? Compared to water, alcohol and petrol. So that we can say their viscosity of this solution, glycerin solution, honey, oil, etc. is more compared to this. An important question most of the people do not ask, or some people may ask, some student may ask, why even measure viscosity? What is the reason of measuring viscosity? Why